Hello friends, it's Mrs. Crane again. I'm here to teach you some more about geometry in 8.2. So what we kind of did today in Math Workshop was we looked at a lot of different angles and we looked at their sizes. And what I want to remind you is that the size of an angle is the amount of rotation or turn from one side to the other side. So like in this angle, it's from here to there. That's the rotation. In this angle, it would be from here to there. That would be the rotation. The size of an angle is measured in units called degrees. And we kind of talked about some of these angles that I'm going to go over in our math workshop today. So it was kind of a precursor. 1 degree is the measure of one very small turn from one ray to the other. The angle has a measure of 1 degree. This angle right here is 1 degree. So the measure of an angle is the total number of 1 degree angles that fit inside of it. So when we're looking at this one right here, oops, this angle right here, there's 1, 2, 3, 4, 5 degrees in that angle. The symbol for degrees is a small raised circle that you can write the measure of the angle. So it's 5 degrees. Now, we've already talked about what a right angle is. A right angle is 90 degrees. And the reason you need to think about rotating or turning, it's in the shape of a circle. So from here, from this flat point to here is 90 degrees. If you were to keep going, you have another 90 degrees, which is 180. If you were to keep going, you have 360 degrees. Now, how do you measure all of this? What do you use? We use something called a protractor, and it's used to measure angles in degrees. This protractor shows angle A, B, C, and measures 90 degrees. Now, the thing you have to look at on your protractor is which way the angle is opening. Because if the angle is opening like from right to left, you use the inner numbers to measure it. And if your angle opens from left to right, you use the outer circle. And I'm not going to have you do anything else on page 300 because we will use a protractor in class. I just wanted you to know what a protractor was and kind of what it looks like. And we will practice with a protractor in a math workshop tomorrow. So you just need to know when it opens from right to left, you're going to use the inner numbers, and left to right, the outside numbers. So don't worry about anything on page 300, but make sure that you have it with you tomorrow. I want you to attempt, top of page 301, to sketch these angles. I mean, use the lines, but you know that a 90-degree angle is going to be pretty square, yeah? You know that a 180-degree angle is going to be straight. You know that a 360-degree angle is going to go all the way around. A 45 is going to be half of a 90. Down here, we're going to use these figures on the right here, and we're going to name one right angle. And so we need to make sure that we're using the angle symbol, and it can be M, this is an R, K, or M, angle M, R, B. Those are both right angles. One straight angle would be angle B, R, K, or angle K, R, B. So it's from here to here. That's a straight angle, 180 degrees. How much greater is the measure of K, R, B than the measure of I, A, O? Well, IAO is 90 degrees, and KRB is 180. So it's 90 degrees greater. Which angle appears to be 45-degree angle? So that's half of a 90-degree angle. So look in this right here. You're looking at angle UA, I think that's an E, or angle EAO. Either one of those is 45 degrees because it's split. Here's my 90. This is half, and this is half. The measure of OAE is 135. Oh, I'm sorry. IAE. This one. From here to here is 135. 135 degrees. What is the measure of OAE? Well, we kind of know that. It's 45. Right? So what is UAE? 45, right? Because these two angles equal 90 degrees. All right, looking at the last page that we've got here. We're going to kind of use some of these angles in the real world. Here's a map of John's neighborhood. The east and the west streets are named for presidents of the United States. The north and south streets are numbered. The avenues have letters. John's house is on the corner of Lincoln and First Street. So let's find Lincoln and First Street. So here it is right here. That's John's house. What do the arrows to the left of the map tell you? Which arrows do you think they're talking about? You're right. It's this directions. It's the compass rose. So it's the directions on the map. So we can tell where north, east, south, and west are. The directions on the map. John leaves his house and rides his bike south on First. So he rides his bike south on First. What kind of angle does he make for each turn in his route? What is the measure of each angle? Yowzers. So John turns southeast onto Avenue A. So he goes from this vertex right here, and he goes on Avenue A. Now, do you think that that's bigger or smaller than a 90-degree angle? It's obtuse. And we'll measure it tomorrow with our protractors, okay? When he reaches Washington, so right here, he turns west. So he turns this way. That is a really small angle. It's so cute. And we'll measure it tomorrow with our protractor. When he gets back to First Street, he turns south. So that's a right angle. And we already know that a right angle is 90 degrees. So John's cousin, Cora, leaves John's house and rides east. I'll use Cora in green. So Cora leaves John's house and rides east on Lincoln. So she's going this way. to Avenue B. Okay? Draw the angle Cora makes if she turns southeast. So it's this angle right here. What is the measure of the angle? So we'll do 16 in class so that you can measure with a protractor. I'm going to show you how to measure with a protractor tomorrow. So the key things that you need to understand today is that measuring angles is all based on 360 degrees, and it's on an opening and closing on that vertex. And like I said, we'll practice a lot of this with our protractors tomorrow. Don't forget to do your Google form. Bye.